Greetings. In this video we'll talk about the center of a group. So if we have some group G, there is something called the center of that group, denoted Z of G. And the way it is defined is that it's basically all the elements in G such that for any element, other element in G, there is commutativity. So it is the elements in G that commute with all other elements in G. That creates basically the elements that are commutative inside G. And by the way, the center of a group creates an abelian subgroup of that group, a commutative subgroup of that group, in other words. So what this means is that it is the set of elements which are commutative with all other elements in the group. So we can take some example of this. A good example to look at could be the quaternion group denoted Q, and what it contains are the elements 1, -1, and then something like an extension of complex numbers for 3D. So ijk instead of just I, minus j, minus k. So these are the 8 elements. It has real numbers 1 and -1, and then it has I, j, k, and minus I, minus j, minus k. And there's the multiplication table for how these interfere with each other. The multiplication table talks about the multiplication of 1 ijk with 1 ijk again, and the results fall into this set. So when we're talking about the center of a group, once again, is the elements from that set of the group, from the group, that will be commutative with all other elements. And from the multiplication table of the quaternion group, which I won't show now, it is evident that many elements don't commute. I times k is not the same result like k times I, for example, or j times k is not the same example as k times j. Usually the result, the difference between these things that could commute but don't, is that one variant is -1 times the other variant. So j times k is -1 times k times j, and so on. But with 1 and -1 it works the same way, it's commutative. So 1 and -1 commute with all the other elements. 1 times k is the same like k times 1. -1 times k is the same like k times -1. And that works. Therefore the center of the quaternion group are precisely the elements -1 and 1. And what we can look at is the fact that this is a subgroup of the quaternion group. So the center of a group is a subgroup of it. Here we see it in this concrete case. And precisely it's also an abelian subgroup because it is abelian. It's all its elements commute with each other. And why is it a subgroup? It has elements that already are contained in the group whose subgroup it is. Also, the results fall again into this group, therefore fall again into the group that whose subgroup it is. And it's abelian because these two elements commute, of course, even with each other. So -1 times 1 is same like 1 times -1.